All right, welcome back, everybody. We are doing the second part of the lesson, and we're going to talk about a lot of the information that we normally think about when we think about lines, starting with slope. So for slope, we use the letter M, and the slope is the rise over the run, and a line has a constant slope, whereas if it's not a line, it doesn't have a constant slope. The rise is the change in y, the run is the change in x, and if we're talking about points x1, y1, and x2, y2, then the rise would be y2 minus y1, and the run would be x2 minus x1, or vice versa. You could say y2 minus y1 over x2, or excuse me, you could say y1 minus y2 over x1 minus x2, as long as you're consistent on the top and the bottom. Okay, now we have several different forms for the equation of a line. Let's start with the one we often think of first, slope-intercept form. It looks like this. Y equals mx plus b. M is the slope. B is the y-coordinate of the y-intercept. Sometimes we're lazy and we just say it's the y-intercept, but I like to give my y-intercept as an ordered pair, 0, comma b. Okay, standard form of the equation of a line looks like this. AX plus BY equals C. So we've rearranged the terms. We have the x and the y terms on the same side of the equation and the constant on the other side. And sometimes different mathematicians will have different expectations, like perhaps one math book will say A, B, and C have to be integers, or they might say that A has to be positive, but I'm not necessarily going to go with any strict rules about that at this point. Usually it's nice if we do have integer values for A, B, and C, not fractions. So I'll just write integers are preferred. And I haven't checked our book to see what it says there. It might be a little bit more strict about that. Point slope form looks like this. Y minus y1 equals m times x minus x1. And actually that is just derived from the formula for slope. If we took the formula for slope that we had back here, and if we just replaced y2 and x2 with x and y, and then we isolated, or we multiplied both sides by x minus x1, we would get this equation. So this equation is handy if you know the slope So use when you know the slope and when you know a point. Then you can substitute them in and you'll have your equation. Okay, let's talk about some specific kinds of lines. Horizontal lines, of course, look flat like the horizon. And so every point on a horizontal line has the same y value. So the equation of a horizontal line always looks like this. Y equals some number k. K is a constant. And how about vertical lines? So vertical lines always look like that. And so every point on a vertical line has the same x-coordinate. So the equation of a vertical line would always be x equals k, where k is a constant. Which of these is a function? Hopefully you said horizontal lines are functions, vertical lines are not. Vertical lines would really badly fail the vertical line test. Now let's look at parallel lines and perpendicular lines and see what we remember about those. So parallel lines, of course, never intersect. So in order for that to be possible, they have the same slope. We should also specify that they have different y-intercepts. If they had the same slope and the same y-intercept, what would be true? It would be the same line. Perpendicular lines have opposite reciprocal slopes. It doesn't matter about the y-intercepts. They could have, oops, I made up a new word. A positive. Ooh, that's a fun word. Let me go back though. That's not quite what I meant. I wonder what it means. Maybe you can think about that. Opposite reciprocal slopes. Okay. The y-intercepts could be the same or different. That's not a particular rule about perpendicular lines. Remember, opposite reciprocals would be something like 1/3 and -3, or -2/9 and +9/2. So you've got the reciprocal relationship as well as the opposite relationship. Okay, let's throw in a couple more things. Function notation. So let's take the equation y equals mx plus b, and let's just write it as f of x equals mx plus b. So f of x is the same thing as y. What we're doing is we're naming our function we're naming our function f as in Frank, and we are saying that what you're inputting is the thing in parentheses. And we're going to practice that a little bit in a minute. Okay, in this class, we often refer to parent functions. A parent function is kind of the most basic of the function family. So if you think of the function family of linear functions as having things like y equals 3x plus 2, y equals 99x minus 741, y equals the opposite of x plus 720, etc., etc. There are infinitely many, but which is the most basic one that all of the others kind of build off of? It would be y equals x. So we call that the parent function. Okay, now let's throw in the midpoint formula, because you may end up needing to find, say, a perpendicular bisector of a line or something like that, and so you might want to find the midpoint between 2 points. The midpoint is going to be the average of the x-coordinates and the average of the y-coordinates. So if your points are x1, y1, and x2, y2, then the midpoint, got to get those letters in the right order there. Oops. The midpoint is going to be x1 plus x2 over 2, because that's the average, comma, y1 plus y2 over 2, the average. Okay, we're going to do a couple of examples. So this first example is just using function notation. This time it's not a line. I could have given you a line. It doesn't really matter. I just made up some function, f of x, and the goal here is to understand what it means to evaluate f of -1. All that means is put -1 in for x and then figure out the answer, or simplify the expression. So f of -1 is -3 times -1 plus 2 times -1 squared minus 1. Of course, we're going to use our order of operations. So we get 3 plus 2 minus 1, so we get 4. F of -1 is 4. Now, it is done. There's nothing else to do. But sometimes people mistakenly think that f of -1 means f times -1, and they think that they have to then divide both sides by -1 to get f by itself. And that is not the case. If you're asked to find f of -1, all it means is, if x is -1, what will the output be? And the output will be 4. If you were plotting the point, you would plot the point -1, 4. Okay, example number 2. Find the standard form equation of the line through the point 3, 4 and parallel to the line 2x minus y equals 6. Okay, so we're dealing with several concepts here. Ultimately, we want the standard form equation, so we'll deal with that at the end. But we know our line has to be parallel to the given line, and remember we said earlier that parallel lines have the same slope. So we need to find the slope of our line. But you can't really tell with the line in the form it's currently in. It's currently in standard form. Let's change it to slope-intercept form. So we need to isolate y. So let's take this equation and subtract 2x from both sides, and now we have the opposite of y equals -2x plus 6, and divide both sides by -1, and we have y equals 2x minus 6. And so now we can see that the slope is 2. Okay. So going back to the problem, we want to find the equation of a line that has a slope of 2 and goes through the point 3, 4. Well, this would be a great opportunity to use point-slope form. Y minus y1 equals m times x minus x1. Let's substitute 4 in for y1, 3 in for x1, and 2 in for m. So we have y minus 4 equals 2 times the quantity x minus 3. Now we need this answer to be in standard form. So I'm going to go ahead and distribute the 2. Y minus 4 equals 2x minus 6. We need the x term and the y term on the same side, so I'm going to subtract 2x from both sides. And we need the constant on the right, so I'm going to add 4 to both sides. Okay, so there's my standard form. Now, if you're required, which I said earlier, in some cases there's a requirement to lead with a positive. If that's the case, then you would multiply the whole equation by -1, and you would get 2x minus y equals 2. I don't particularly care at the moment whether you leave it the first way or if you multiply by a negative. Okay, let's see what's hiding under this box. I don't even remember, so this is pretty exciting. Oh, yes, I love this kind of problem. It incorporates a lot of ideas as well. This will be our last example. Find the equation of the perpendicular bisector to the segment with endpoints 3, 4, and -2, 0. Okay, so let's visualize this. I'm going to make a little sketch. We have 2 points, 3, 4, and -2, 0. Let's make a little sketch of that. It doesn't even have to be perfectly to scale, but the more it is to scale, the easier it will be to visualize if our answer makes sense. By the way, whenever you're drawing a graph, make sure to label your scale. So 3, 4, -2, 0. Okay, there's a segment that connects those points. We want the equation of the perpendicular bisector to the segment. That would be the line that goes through the midpoint. So let's roughly estimate the midpoint and is perpendicular to the line. So that's going to be something like that. Nice and straight there. Okay, so just by looking at the sketch, we can see some things about the line. It looks like it will have a negative slope. It looks like its y-intercept is going to be somewhere around 2. So let's keep that in mind as we're doing the work. Let's find that midpoint. So the midpoint is going to be the average of the x-coordinates, comma, the average of the y-coordinates, and that simplifies to be 1/2, comma, 2. Okay, we also need to know the slope of our line. To find the equation of the line, we need a point and a slope. Now we have a point. To find the slope, we'll start by finding the slope of the segment. And so we can take y2 minus y1 over x2 minus x1, and we get -4 over -5, so 4/5. And so from that, the perpendicular slope would be the opposite reciprocal, and that would be -5/4. So let's use these two pieces of information along with our point slope form. Y minus y1 equals m times x minus x1, and we'll find the equation of the line. Notice it just said find the equation. It didn't say what kind. So by default, let's just find the slope-intercept form. Okay, so we have y minus 2. 2 was the y-coordinate of the point, equals -5/4, the slope, times x minus 1/2, the x-coordinate of the midpoint. Okie dokie, and now we are going to change this to slope-intercept form. So let's distribute the -5/4. Y minus 2 equals -5/4 x plus 5/8. And then let's add 2 to both sides. And we know that 2 is equivalent to 16/8. So we're adding 16/8, and that's going to give us 21/8 altogether. So that's the equation of the perpendicular bisector. Okay, the y-intercept is the point 0, 21/8. Is that somewhere between 2 and 3 like we were expecting? 2 would be 16/8, 3 would be 24/8. So yeah, that makes sense, and that matches with what we have in our sketch. And we did get a negative slope as well, and so that makes sense. We were anticipating that. Okay. So this assignment that you're looking at right now looks like a lot, but it's going to be a 2-day assignment. So next time We're not going to have a new lesson and we're not going to have a new assignment. We're just going to go over questions that you've come up with so far, and then you'll just keep working on this assignment. Okay? Hopefully that makes sense. And ask questions if you have them, and thank you for watching this long video.